Hello. Let's look at this question. First of all, we must understand there is this drag force acting on the vehicle moving at a steady speed of v through the air of density rho is given by this expression. What does that mean? Okay, this Fd refers to frictional force acting on this car. Okay, in this case, the A is the cross-sectional area of the car, the rho is the density of the air, the v is the speed of the car, CD is the drag coefficient, which is not important, the drag coefficient remains constant. Now for this question A, we must first understand that this car is moving in a horizontal road, requires 60 kilowatt to travel through still air at 80 km per hour. That means the car here is moving at 80 km per hour, okay, and it has certain power production. The power generated here is 60 kilowatt. We also understand that power is big F times V. Okay, this one is very important. We need to understand that power is big F times V. Okay, this one, they say that travel through still air 80 means what? Means this 80 is a constant speed. Okay, when constant speed, that means what? That means this big F and this small f must be equal. Do you know why? Because at constant speed there is no resultant force acting on this car. When there is no resultant force, that means the forward force and the backward force is the same. Alright, now in this case, since this one is big F times V, this one is small f. Okay, let's make them equal. This one I also can put the V as well, because both also are moving at V, right? The V is constant at 80, so this is Fv, this is big F. They must be equal. Then only there is no acceleration, the object will move at constant speed. Okay, what is F? Okay, in this case, we know that F, which is the drag force here, is equal to CD A rho V square, right? Now look at this one. This one actually, this is actually the frictional force. Okay, now, so in this case, we know that this forward must be equal to this backward value. So in other words, this one also equals to small f v. Okay, now small f is what? CD rho A v square times the v, the f is this one, times v, so becomes CD rho A v cube. Okay, now and this is actually equals to 60 kilowatt. Keep this equation. Okay, now for this second part, they say give a quantitative explanation as to why the power required is greater when traveling at a headwind of 10. What is the meaning of headwind of 10? Headwind of 10 means additional 10 km per hour. You move at faster rate at 90 km per hour, in other words. This one becomes 90 km per hour. That means you move faster. Obviously, when you move faster, there's additional headwind of 10 km per hour, additional frictional force acting on this car in this direction, right? So it's the same. This one is Fv. This one is also power, also Fv. But this one we do not know. This one you need to find. What is the value? Since you know at 90 km per hour, this one also means moving at constant speed. Okay. Now, what is the meaning of this one and this one? Are they the same? Yes, because they're still at constant, but now become 90. So F, bring here, so it's Fv is equals to power as well. Okay, but this F become what? This small f? This small f is against CD rho A V square times the V again become CD rho A V cube. Okay, now this is second equation. Let's solve these two equations. See what do you get. Okay, let's use a second equation divided by the first equation. So look at this one. Second equation is what? P divided by 60,000. So P divided by 60,000 equals to CD rho A V cube. CD rho A V cube is a V is what? V is 90 kilometer per hour. 90 must change to SI unit per hour. Per hour, 1 hour, 60 minute, 1 minute, 60 second. Cube divided by CD rho A V cube. CD rho A V cube. But the V at the beginning is only 80 kilometer per hour, so we need to use 80 convert to SI unit, becomes meter per second. Okay, now do some calculation. You see the friction of coefficient, the CD here, the drag coefficient is the same, so we can cut the density of the air also the same, cut because we are using the same car, so the cross section area also the same, cut. So just divide them accordingly. The power you will get is approximately 85430 watt, which is much greater than this 60,000 watts. That's how we solve this question for part A. Alright, now what about part B? Okay, look at this trailer here. Okay, this is a trailer. Why they say why must be fitted in such a way? They say sometimes fitted with an inclined plane on its roof. Why we need this inclined plane? Because this one is to smooth the movement of the air. The air should come here smoothly. Do you know that without this inclined plane, there will be large friction acting on this sharp surface here, and it will cause this car to experiences large friction. Therefore, it cannot move forward with greater speed. This one will have a lot of power losses. That's why we need this smooth inclined plane to streamline the movement of the air in order to reduce power losses in the system. Hence, we can improve the efficiency of the truck.